remote desktop credential theft with Seth. In this demonstration, we're going to look at a scenario involve a victim that wants to establish a VPN connection to a trusted corporate resource. In doing so, the victim has to connect to an access point. In this case, we will look at a compromised home router, for example. So, the idea is you connect to the Wi-Fi and you have your VPN running, and you should be safe, right? But what if that access point is compromised? Well, what can the attacker do? We're running a VPN, right? So the idea is that what we're going to look at is take a RDP session and see if we can't mess with that RDP session. So the victim in this case wants to RDP into the corporate network over the VPN connection. Once again, it should be safe, right? That's our assumption. Is there a way we can steal credentials? Well, the idea is simple. Our premise is simple. What we're going to do is, because our attacker controls the home router, right? We've compromised it, and we can then influence how the traffic gets controlled. Our attacker in this case also sits in this. We're just going to assume they're sitting close by on the same local network through another compromised device, or on the same router for that matter. It's not really an issue. It's just we're going to demonstrate how we're going to redirect remote desktop connection. But what we're going to do is we're going to use a DHCP route that we're going to inject. Because the attacker controls that home router, we control DHCP as well. And basically what we're going to do is, because of that route, we can actually say for certain traffic, push it to our attacker device. And that should give us the ability then, if we are spot on with our IP that we're going to redirect, to actually move the traffic out of the tunnel for the RDP session and push it to the attacker's machine. Now, VPNs are not supposed to do this, so there's something called root precedence that's supposed to protect this, and it does if it's enabled and if your VPN supports that feature. Most enterprise VPNs do, but if you don't enable that feature by default, then this type of attack is going to be possible. Tools in this case is going to be a couple of things, like if you look at the virtual host we're going to use, we're running a Windows machine in a VM, and we're using a Wi-Fi adapter to actually breach the network into the real physical world. Then we also have a physical host, which is going to be our attacker platform. That's going to run our the DHCP server that we're going to mess the root injection with, as well as our malware, or Seth person in the middle service is going to run there as well. And next we're also going to have a Wi-Fi access point. This is a physical Wi-Fi access point which we're going to use to communicate through between the breached virtual host and the physical host. So this is basically just our little lab setup. In other words, just the three items really. The virtual machine sitting in VMware on my laptop, like I said, with a breached USB Wi-Fi adapter, because that's what I have, and then our access point, which the attacker has, and our attacker machine. So it's a simple lab setup, nothing complicated there, all in their own little subnet. Next, like I talked about DNS mask and DHCP. So DNS mask, we can use any version of DNS mask. If you run Kali Linux, it's installed there by default. Otherwise, you can just get that off whatever package manager you're running, and then install that and configure it. I'll show the basic configuration that you need. And the simple thing is going to be one DHCP option that we need to tweak. Here it is. Here's the configuration, and if you look at the configuration specifically, I mentioned DHCP option. It's going to be DHCP option 121, and what we're going to look at is we're going to home into this little section here, and this section basically is the static route that we're going to inject for our host, our victim. And that basically says take the 192.168.60.122 address for that host and just make sure the traffic routes to 192.168.87.252, which is our attacker IP address. And what we've done is we've basically set up that 192.168.60.122 address, and it's also bound onto that attacker machine. So that attacker machine's got 2 IP addresses, but it acts also as a gateway with this configuration. And then what will happen is we're going to use this to our advantage to actually get a connection breakout out of our VPN because root precedence is absent. Next, our tool that we're going to use to capture the credentials with is created by Adrian Vollmer, and it was purpose built for this person in the middle style attack to show that we can steal credentials from RDP sessions. Although we can't necessarily intercept the RDP session, it should be possible if you have the correct Intel M signing available as well as the certificates, etc. But I mean, that's just a bit too much for this demonstration. In theory, you should be able then to ride on that session, which is unlikely in most cases, but the idea is we want to use this tool to capture credentials. So if you can download it through this GitHub repository, it's a Python script that you run, and you need to give it a couple of parameters. In this case, you'll see here there's like, I think, 3 sets of parameters we need to give it. We need to give it like a cert at least, and a key, just so that we can do the initial SSL handshake or TLS handshake for the RDP session that's going to come in. Remember, the RDP host is going to connect to us, so it's going to try and, the RDP client is going to connect to us, and it's thinking that it's talking to a RDP server. So Seth emulates that RDP server behavior, and that's why this certificate is important, because that channel is encrypted. Next, we need to specify Seth to bind to this IP address that we going to mimic for our victim, for our target host that we are basically person in the middling as, and basically just listening on this port. So when the root jumps out, it gets redirected to our attacker host. This IP address will be ready and waiting for it because it's sitting on the same LAN as well as the victim, and effectively we can then capture this. We can start with this process. And here's just another IP address that we're going to redirect our Seth connection to, so that at least it facilitates both sides. This IP address can be anything, any real RDP session preferably, so that at least it makes it just much easier in the beginning for Seth to get going. So we have that running, and then let's start off with the actual attack. Here you see we have the victim host machine running Windows, and we basically have our VPN sitting there on the right hand side. It's going to connect eventually, but we need to connect to the Wi-Fi, so our captive portal, our home router, compromised access point in other words. And once it's connected, it gets a DHCP address from our attacker machine with the specific route already present, and we start our VPN. And just to show that there's activity, you see here's the IP address of our current LAN adapter, and here to show the net routes, specifically the full tunnel enabled here. The VPN is supposedly capturing all network traffic and pushing it through its adapter. But what we've done is with our DHCP route, we've injected it to say, well, for this specific host that we're interested in, just direct it to this gateway, which so happens to be the attacker's IP address. And then, all traffic's going there. And the whole idea is now traffic is not flowing through the full tunnel, although full tunnel is set. It's because root precedence is absent. So yeah, here we start our remote desktop connection. to an IP address. So the victim is now going to connect, and what happens is on the initial connection, Windows tries to be helpful and just tries to authenticate first using Intel M hash, but what's happening is Seth captures that Intel M hash here for us, and it fails, and then Windows realizes, oh, it fails, that's funny. Maybe we just specify the credentials anyway, so we have a user already filled in there as a username, and let's type in a password. In this case, we have got some secret password there that we just seeing there, and we authenticate trying using that. And now we see, oh, wait a minute, certificates are wrong on this host we're connecting to. But in my experience, and I think some of yours experience as well, that Windows, this is not that uncommon, right? This type of certificate shenanigans on Windows side, it can occur, and most users aren't technical, right? If they're not really paying attention to this, they can just say, okay, yes, I don't know what this means, but Windows gives me the option for this to continue. And even if you look at there, it says don't ask me again for this computer, so you can even remember that if you want to, right? So you just say yes in this case, and then what happens is voila, connection continues, and now we've got username and password. Although the connection is not going to necessarily continue, we at least have username and password. That's all the attacker really wanted, right? So just a simple scenario that can happen, that shows that this is possible just because root precedence on that VPN wasn't present initially. Hope you enjoyed. Thank you very much.